What's up, guys? Today we're going to solve problem 7 from dailycodingproblem.com. Good morning. Here's your coding interview problem for today. This problem was asked by Facebook. Given the mapping a equals 1, b equals 2, all the way up until z equals 26, and an encoded message, count the number of ways it can be decoded. For example, the message 111 would give 3, since it could be decoded as AAA, KA, and AK. You can assume that the messages are decodable. For example, 001 is not allowed. So let's take a closer look at this. We're given this mapping here, which are just the letters of the English alphabet and their corresponding numerical values. And we're given an encoded message. We need to write a program that determines the total number of ways you can decode this message. In this example, we could decode this as AAA right here. We could decode this as 11 and then 1, which would be KA right here. Or we could decode this as 1 and 11, which would be AK. So we would return 3. 3 total ways to decode it. Let's look at a couple other examples here. So if we were given 26, decodings for this would be 26, which would be BF, I think. Or we could look at this as the value 26, which would be Z. So here we would return 2 in this example. If we were given 101, decodings for this, well, we can't do 101 because 0 is not valid. We can't do 1 and then 01 as a 2-digit number. That doesn't work. We have to decode this as 10, 1, which would be JA. So here we would return 1. Let's look at one last one. If we were given 602, so how can we decode this? Well, we can't do 0. We can't do 02. If we were to look at this as 60 and 2, that doesn't work either because 60 is greater than the maximum value in our mapping here of 26. So there actually are no ways to decode this one here. So here we would return 0. Now how can we write a program that does this? The solution I'm going to show you is the one provided by dailycodingproblem.com. So if you were to subscribe to their mailing list and pay for solutions, this is the one that they would send to you for this problem. We're going to create an array that is going to store the total number of ways that we can decode this message. Next, we're going to iterate over our encoded message from right to left, so from the end to the beginning, and we're going to look at each character along the way, and we're going to compute the total number of ways that you can decode the message from the character at I to the end of the string. And we're going to store that value in the corresponding ith position of the array that we created. So let's type that up in note form here. So we'll create an array. Next, we'll iterate over our encoded message from right to left. So we'll say for n to 0, we will iterate over encoded message. And along the way, we will check the character at I, so single characters at I. And we will check 2-digit characters. So we'll say the characters at I and I plus 1. And we don't need to worry about checking 3-digit characters because it has to be less than 26, and we know values like this don't fly. And then in the corresponding ith position of our array, we will store the total number of ways that you can decode the substring from the character at I to the end of the string. So store number of ways to decode from character at I to end of encoded message. That is wordier than I intended that to be. And as we go, we're going to be building up our solution from right to left. So that means the value at index 0 of our array will contain the total number of ways we can decode the entire string. So that means at the end we need to go ahead and return array at 0. And this solution will work in big O of n. Okay, so let's go ahead and start coding this up. And once we finish, I'm going to walk through an example, a couple examples actually, very slowly. So hopefully by the end of this it makes sense. And we'll give our solution its own method, as we do. So our encoded message will just be a string. And let's use 121 for this. To test it, we will just print out a call to our solution method, passing in this string. All right, so we'll use our notes as a guide. The first thing we need to do is create an array. So this will be an integer array because it's going to store values for us. And we will call it just number of decodings, that's fine. All right, and we're going to set its length equal to the length of the string plus 1. And then we're going to set the last value in this. So the very last value must be equal to 1. So encoded length in this example would be 4. We're going to set the last value, encoded length here is 3. So this means the index at the third index, which is going to be the last value in the array, is equal to 1. This must be done in order to account for these final 2 digits. It doesn't matter how long the string is, it's necessary for that reason. And once we walk through an example, you'll see why that is. Okay, next we need to iterate from right to left. So we will do that. And we'll decrement I. All right, so first we'll check individual characters. So we will see if the character at I is equal to 0, which is a character. If it is, then we need to set the corresponding value in our array equal to 0, because there are no ways that we can decode 0. It's not valid, so must be set to 0. Next, we use an else if here. Must be an else if, not just an if. We are going to check to see if we're looking at the very last digit in our encoded string. So to do that, we'll say is I equal to the length minus 1. So in this case here, we're looking at this very last value. Now if we're looking at this very last value here, if it's equal to 0, we'll handle that here. Otherwise, it's going to be equal to 1 through 9, in which case there is going to be one way to decode it. So we need to set that equal to 1 for sure. All right, next we will account for 2-digit numbers. So let's just create a variable to store that. And we'll use Java's built-in method here to convert our characters into a 2-digit number. Now, let's refer to our notes here real quick. We're looking at the characters at I and I plus 1. All right, so we've got the character at I plus 1. Now, what do we need to know about that? We need to know if it's less than 27, because if it is, then it is a valid decoding. Now, if it is less than 27, what we're going to do is we're going to set the corresponding ith value to what is in the array at I plus 2. So we'll set it to num of decodings at I plus 2, which is simply the value before we encountered this 2-digit number. That's all it is. So after that, we need to go ahead and set this, we need to increment this, actually, equal to num of decodings at I plus 1. So if it's less than 27, here we update this with the total number we had before our 2-digit number. Here we increment it including the number of ways you can decode the 2-digit number. All right. Now, if that still doesn't make sense, we're going to walk through it in just a second, and hopefully it will once we walk through it. So the last thing we need to do here is return the first value in our array. And before we run this, let's print some things out just to give us a visual here. This is difficult to understand, so hopefully with this it'll make it a little more clear. This is simply going to denote an iteration. And let's print out our array each time we update it. We'll just use checkpoints here. And let's also keep track of I along the way. Okay, and let's print it out for each one of these statements. Let's call this checkpoint 1. We'll call this, oh, I don't know, checkpoint 2 and checkpoint 3. And we will also print out our 2-digit number here. So we can get a good look at it. All right, let's run this. So in this example, we expect 3 because you can decode this as 121, 121, or 121. And that is what we get. Let me run this again real quick, and I'm just going to print this out on a new line. So when we go through it, it's not so close together. All right, now let's walk through this thing. Let's bring down our encoded message here so it's front and center as we look at this. So we're starting from right to left. The first value we're looking at is 1. That's not equal to 0, but we are looking at this here. So I is equal to encoded.length minus 1. So we need to go ahead and set that equal to 1, which you can see we do right here. Right? We're at checkpoint 1. I is equal to 2, 0, 1, 2. We set this equal to 1 right here. Remember, we already set this equal to 1. And in a minute, you're going to see why we had to do that. All right, next we decrement I. So we're looking at this value here. Is that equal to 0? No. Is this true? No. Now we go ahead and get the 2-digit number, which is I and I plus 1. So we're looking at 21 here. You can see it right here. So here we go ahead and set the ith value in our array equal to I plus 2. So that's right here. We set this equal to I plus 2 right here, which is just the value that we had before we encountered our 2-digit number. Next, in checkpoint 3, right here, you can see that we go ahead and we increment this by I plus 1. So we take this plus I plus 1, which gives us 2 right here. Remember, we're storing the total number of ways we can decode the substring from the character at I to the end of the string. So I in this case is 1, so this is the substring we're looking at. There are 2 ways to decode 21. It can be decoded as 21 or as the character 21. This would not be possible to achieve without this 1 right here. The way we have this set up, it would not be possible to achieve without having this 1 right here. That is why it is necessary. All right, next we decrement I, and it is now 0. So we're looking at this value here. Is that equal to 0? No. Is this true? No, it's not. Now we look at the 2-digit number of I and I plus 1. So we're looking at 12. 12. You see that right here. Is that less than 27? Yes. So now we need to go ahead and we need to update this with the value that we had before the 2-digit number. All right, now that is correct. The 2-digit number is 12. 2-digit number is 12 right here. So we set it equal to the value we had before that, which is 1. Next, we go ahead and we increment I right here with I plus 1. All right, number of decodings at I equals to number of decodings at I plus 1. So we take 1 plus 2, and this updates to 3, which is our solution. Okay. Now let's look at a couple other ones here. Let's just look at 10. Let's look at 10 real quick. All right, we'll run 10 so we can see that it works as well with this. Now, there is only one possible way to decode this. You can't do 1, 0, so this is simply 10 on its own. All right, and let's update this here. So on the first iteration here, remember we set the last value equal to 1. So we've got two digits or 2 characters in our string, but we have three spaces or length of 3 in our array, and we set the last value equal to 1 each time. So here you can see that, and we've got our character at I is going to be this one here. So this is equal to 0. So we go ahead and set I, which is 1 right here, equal to 0. You can see that right here. All right. Next we decrement, and we're looking at this character here, 1. Okay, we're looking at 1. So we check to see, is it equal to 0? No. Is this true? No, it's not. So we come down here, and now we've got our 2-digit number. We've got 10. So we're looking at the entire string. Is that less than 27? Yes, it is. So therefore, we're going to update it with this value here. So you can see here we update it with I equals I plus 2. That gives us the 1 that we need for this. That's our solution. Because here, whenever we increment it by I plus 1, that's going to update with 0, which is technically correct because this is not a valid decoding. So we set that equal to 0, and that gives us our correct solution of 1. Okay, hopefully that makes sense. You can see how that works. We can, just so you can see it works even when it's 0, we'll run 602 real quick, but we won't walk through it. So here we expect 0, and that's what we get because there are no ways you can decode the string of 602. So I would recommend just typing this up the way we did it and running this on your own and walking through some of these so you can see how it works, because this one's a bit tricky. All right, if you have questions, leave them in the comments. If you have a request for one of these you'd like to see, leave that in the comments as well, and I will do it for you. Stay hard, guys. See you next time.